The Bioproduction and Machinery Lab, or BPM, has envisioned a new era for humanity, Society 5.0, that is driven by smart agriculture innovations. To this end, the BPM Lab has been continuously aiming to channel cutting-edge technologies such as AI, Internet of Things, and robotics through mainly two research initiatives. One of our first works was focused on automated landmark-based navigation using LiDAR. Some of the applications were automated approach and navigation to an implement, automated loading and unloading using road cones as artificial landmarks, and so on. An autonomous leader-follower system using stereo vision was also developed. We are also targeting to adopt the leader-follower system to what is called the swarm application, where UAVs will serve as leaders of multiple coordinated small mobile robots. To avoid accidents in farms, a member of our lab has developed a system to detect accident-prone facial and body expressions in farmers using Kinect's sensors. Also, accident-prone signs from the road's perspective are also monitored in this system. Based on these risk classification level, a rescue message will be sent automatically to the family or the community. Next is the precision orchard spraying system. To reduce the agricultural chemical application, we have developed a smart spraying system using deep learning algorithms to classify non-spraying and spraying areas. Recently, UAVs have been gaining momentum in smart agriculture, especially for small-scale farmers. More importantly, small embedded computing boards makes it possible to develop smart UAV systems. One of our works is the development of a uniform seed broadcasting system using UAVs. In this research, the system was based on the orthomosaic and sparse digital surface. We have also studied different state-of-the-art machine learning and deep learning algorithms for UAV-based site-specific weed sprayers. One was spray and non-spray area recognition. Next is the classification of the weed proportion as basis for the herbicide amount in cabbage fields. And just recently, a real-time weed detection was also developed for green onion fields. Other than weed management, real-time size-based grading of cabbages was also done using deep learning. Other than automation, UAVs can also be used for remote sensing to guide the farmers in their decision-making. UAVs can be used to remotely sense different plant parameters such as moisture content, tea quality, plant height, and biomass. This enables faster crop monitoring in farms. Satellite-based remote sensing can shed light on the geographic relationship of economic, social, and environmental dimensions, which is important for regional level of decision and policy making. Some of the most common remote sensing satellites are Sentinel, Landsat, and MODIS. Using these satellites in combination with publicly available dataset, some of the remote sensing studies that we have done are the following: yield forecasting for rice and grapes, site-specific crop suitability analysis for corn, Arabica coffee, cassava, rice, and tea. Risk assessment from natural disasters such as flash flood and drought. Regional land planning for nutrition security. And finally, forest carbon stock analysis. One of our research group has been focusing on the renewable energy utilization in Asian and African countries. To address the carbon dioxide and methane emissions in agriculture, we have also researched about energy balance for environmental sustainability for palm oil plantation and sugarcane production in Southeast Asia. Also, we have engaged in research about third-generation biofuel production from microalgae. Recently, life cycle assessment was used in the forecasting of biodiesel production from upstream to downstream process at the Minamisoma of Fukushima Prefecture. Also, collaboration continues in doing further research in water utilization fingerprint from household to agriculture. At the same time, rice husk combustion, which contributes to PM 2.5 air pollution, can cause serious health risks. Our research approach deals with the optimization of combustion temperatures that result to less carbon dioxide emissions, which can ensure safety in agricultural production systems. Overall, optimum utilization of bioresources could safeguard the sustainability of the environment and agriculture. Research and development on smart agriculture and renewable energy is advancing more than ever. Several universities and institutes around the world have joined us towards our vision of Society 5.0. Annually, we hold a session in the Tsukuba Global Science Week to discuss about the possibilities of AI and IoT in agriculture in achieving the SDGs. One may think that we are a step closer to our goal. However, digital technologies are still growing, even faster than before. Join the journey of the BPM Lab in ushering agriculture to a new era. Let's grow together.